Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, I want to talk about the XAML syntax that we wrote in our first pass at the Pet Sounds project. Hopefully you could see how the XAML that we wrote impacted what we saw in the preview pane for our main page.xaml. It's relatively easy to figure out the absolute basics of XAML just by looking at it, right? However, I want to point out some of its features and functions that may not be so obvious, at least at first glance. So at a high level, our game plan is this. We're going to talk about the purpose and the nature of XAML, comparing it to C#, and then we're going to talk about the special features of XAML, little hidden features that may not be so obvious by just staring at it for a while. So my aim is that by the end of this lesson, you're going to have enough knowledge that you can look at XAML that we write in the rest of the series and be able to make a pretty good guess at what it's trying to do even before I tell you what it's doing, all right? So in the previous lesson, I made this passing remark about XAML and how it looks similar to HTML. That's no accident. XAML is really just XML, the extensible markup language. I'll explain that relationship in just a moment, but at a higher level, XAML looks like HTML in so much that they share a common ancestry. Whereas HTML is specific to structuring a web page document, XML is more generic, and by generic I mean that you can use it for any purpose that you devise. You can define the names and the elements of the attributes to suit your needs. So in the past, developers have used XML for things like storing application settings or using it as a means of transferring data between two systems that were never intended to talk to each other. So to use XML, you define a schema which declares the proper names of elements and their attributes. A schema is kind of like a contract. Everybody agrees to the contract, both the producer of the XML and the consumer of the XML. They agree to write and to read the syntax of a particular flavor of XML in a specific way to conform to the rules that are set up in the schema. So they agree to abide by the rules of the contract. Now they can communicate with each other because they have common rules that they abide by. So a schema is an important part of XML, and just keep that in mind because we're going to come back to that in just a little bit. XAML is a special usage of XML. Now obviously we see that, at least in this case, XAML has something to do with defining a user interface in our phone app's UI. So in that regard, it feels very much like HTML, but there's a huge difference. XAML is actually used to create instances of classes and set the values of properties. So for example, in the previous lesson, we defined a button control like so, right? And if we were to try to recreate this one element, this button element, with all of its attribute settings and everything in C#, it would look something like this. And give me just a minute because I'll be doing a lot of typing here, okay? Just to prove my point. Okay, so as you can see, I added the C# code in the constructor of my main page class. I'm going to talk about the relationship in a little bit more depth. We already kind of alluded to it in the previous lesson, how there's a relationship between the main page.xaml and the main page.xaml.cs, that they're two parts of one whole. We'll talk about that more in just a moment, but we've already seen how we can define the user interface in the XAML page and then define the behavior of the various XAML elements in our main page.xaml.cs by writing procedural C# code. So here I'm merely writing code that will execute as soon as a new instance of the main class or the main page class is created by writing code in its constructor of that class. So at this point now, I have two buttons, one defined declaratively in XAML that has the content quack and will quack whenever we click a button, and a second button that has the content of meow. And so when we run the button, or run the app, we only see one button. Why did that happen? Well, that's because the button that we just created procedurally in C# in the constructor of our main page class is sitting on top of our previous button that we defined in XAML. And so just to prove it, what I want to do is add one more line of code that will move our new button out to the right-hand side. So here's what we'll do. All right, so the margin property of the button class is of type thickness, and thickness is a general purpose class that represents 4 dimensions. In this case, we create a new thickness class and set its first value, the first input parameter argument, to 210 pixels. And so when we run the application again, you can see that we now see both buttons because it moved that meow button over to 210 pixels to the right-hand side. So the larger issue is that we have two almost identical buttons, one created declaratively in XAML and the other created procedurally in C#. When I create a new XAML element using this open and close element syntax like so, open button, close button syntax, I'm basically creating a new instance of the button class. When I set attributes like you see here on a button element, I'm basically setting the properties on that instance of the button class. So the important takeaway is this: XAML is simply a way to create instances of classes and to set those objects' properties in a much more simplified, succinct syntax. What took us, look, how many lines of code here? Well, maybe like 10 lines of code in C#, we were able to accomplish in just essentially one line of XAML. Even if I did separate it onto different lines in my editor, it's still much shorter than it would have been had I used C# to create all of my objects. Furthermore, using XAML, I've got this immediate feedback in the phone's the designer preview pane. I can see the impact of my changes instantly. In the case of the procedural C# code I wrote, I'd have to run the app each time that I wanted to see how my little tweaks actually impacted the layout of the app and all of its interface elements. All right, so if you have a keen eye, you might notice the difference in XAML and the C# versions of the buttons that I created when it comes to the horizontal alignment properties. So you can see horizontal alignment equals left, vertical alignment equals top. And if we were to take a look here in our C# version, we're actually creating instances of system.windows.verticalalignment.top. It's an enumeration. What if I were to change, for example, this horizontal alignment from system.windows.horizontalignment.left to just the string left? If I were to attempt that, you see a red squiggly line immediately, and if I were to try to build our project, our solution, we're going to get an error, a compilation error, cannot implicitly convert type string to system.windows.horizontalignment. All right, so the XAML parser will perform a conversion to turn this string of left or top through the use into the value system.windows.horizontalignment.left in this case, through the use of something called a type converter. A type converter is a class that can translate from a string value into a strong type. And there are several of these that are built into the Windows 8 Phone 8 API that we're going to use throughout this series. In this example, the horizontal alignment property, when it was developed by Microsoft's developers, was marked with a special attribute in the source code, which signals to the XAML parser to run the string through a type converter method to try and match up the literal string left with the enumeration value of system.windows.horizontalignment.left. All right, so just to show you what happens if you were to try and misspell the word left. Here, I'll just take the L off of left, and notice that we get a blue squiggly line under the word horizontal alignment. How does it know that it's just a string value, right? I should be able to type anything in here. I should even be able to type Bob, and it would take it and maybe give me some kind of runtime error while I'm actually running the app. But you get a compilation error because the type converter can't find an exact match that it can convert into the enumeration value system.windows.horizontalignment.left. So let's go ahead and change that back. All right. So the first characteristic of XAML is that it's a succinct means of creating instances of classes. In the context of building a Windows Phone 8 application, it's used to create instances of user interface elements. However, XAML is not just a user interface technology. It could be used for other purposes in other technologies, and it is, as a matter of fact. All right, so next up, let's talk about all that XAML code at the very top. Before I forget, let me go ahead and change this back as well, because this isn't going to work. If we try it again, Windows.horizontalalignment.left. There we go. Okay. So now let's move over to the main page.xaml, and let's take a look at the very top of that file where we see this phone application page, and it's just one really long element declaration. If we look at the very bottom, we can find its corresponding closing element. Okay, so what's the purpose of this? Well, while you're looking this over, remember what I said a moment ago about schemas being a big part of XML. If that's the case, then where does this XAML promise to adhere to a schema? Well, take a look at lines 3 through 8. These lines of code right here. There are actually 6 schemas that this main page.xaml is promising to adhere to. Each of them are defined with this XML-NS attribute. The first XML-NS or XML namespace defined in line 3 is the default namespace. In other words, there's no colon and no word after it like we see in the ones that follow it below. All right. So the rest of the namespaces here in lines number 4 through 8, they use the name XML namespace and a colon and another value. So just to be clear, the :x or the :phone or the :shell is the namespace that's associated with a given schema, what we called a contract earlier. So each element and attribute in the rest of this main page.xaml must adhere to at least one of these schemas that are defined at the very top of this XML document. Otherwise, the document is said to be invalid. In other words, if there's an element or attribute expressed in this XAML file that's not defined in one of these namespaces, then there's no guarantees that the compiler, which is the program that will parse through all of this code and will create an executable that will run on the phone, there's no guarantees that the compiler will be able to understand how to carry out that particular instruction. So in this example, in our grid, our content panel grid, all right, we have this grid and then xname equals content panel and so forth. We would expect that this element grid would be a part of the default schema corresponding with the default namespace located here in line number 3. However, its name, this x::name equals content panel, we would expect it to be defined as part of this namespace here because it is prefixed with the letter X, which is defined in line number 4 here at the top. All right, so I have a bright idea. Let's try to navigate to this default namespace. I mean, it's http:// some schemas.microsoft.com. Let's take a look at what a schema actually looks like. So let's select it. I'm going to hit Control-C on my keyboard. I'm going to open up Internet Explorer here. And I'm going to paste in the URL. And whoops, an error occurred while processing your request. Well, what in the world just happened? Well, the schema doesn't actually exist at that URL. That's because a schema is not published in the sense that you can go to that URL and view it. Instead, a schema is simply a unique name, similar to how we use namespaces in C# to identify two classes that might have the same name. The schema, and therefore the namespace in our XAML, keeps class names sorted out, kind of like a last name or a surname. So this URL, or more properly, we should refer to it as a URI, a Uniform Resource Identifier, rather than a URL, which is a Uniform Resource Locator. So this URI is used as a namespace identifier. The XML namespaces are simply instructions to the various applications that will parse through the XAML. With the Windows Runtime XAML parser will be seeking to turn it into executable code, while the Visual Studio and Blend designers will be seeking to turn it into a design time experience. So the second XML namespace defines a mapping, this :x, as belonging to this schema, schemas.microsoft.com/winfx/2006/XAML. Therefore, any attributes or element names that are preceded by the X prefix means that they adhere to this second schema. So what's the difference? Well, it's subtle, but the second schema defines the intrinsic rules for XAML in general. The first schema, our default schema, is actually defines the contract or the rules for Windows Phone 8 specific usage of XAML. In other words, the fact that we can work with the grid or the button or the media element and the other Windows Phone 8 XAML elements without using a prefix means that they're defined in the default namespace. All right, so now let's take a look at lines number 5 and 6. You can see that they're at a different URI, one that takes its cues from the Microsoft.phone CLR namespace and are defined in assemblies called Microsoft.phone. And these were installed on our computers when we installed the Windows Phone API 8.0. So you can see actually where this phone prefix is used here for the phone application page. If we were to take a look at phone application page, let me just do a quick little bit of investigative journalism here. And let's search for this in Bing.com and find this in on MSDN. And let's take a look at the hierarchy. You can see that as we work our way back through this from Microsoft.phone.controls.phone application page, of course this Microsoft.phone.controls, which we see here is the namespace that it derives from system.windows.controls.page, and it works its way back all the way to system.object. But this system.windows.controls.page is actually used by other frameworks like the Windows Presentation Foundation page classes and Windows Store apps. So for Windows 8 apps, those page classes as well. So a lot of the base functionality is shared by all three of these project types: WPF, Windows Store apps, and now Windows Phone apps. So the upside is that you're able to leverage what you learn in this series of building Windows Phone apps to also WPF desktop apps and Windows Store apps as well. Of course, there will be differences, but there's a lot in common too, and so we can trace that lineage back. But at any rate, these namespaces are defined in as CLR namespaces, all right, instead of this HTTP syntax. Lines 7 and 8 here, you can see they define namespaces and schemas that are used to allow Visual Studio's phone preview pane on the left to display properly. These instructions are ignored at runtime, which is what line number 9 is doing right here. So when compiling the XAML code, ignore anything that's prefixed with the letter D. All right. Okay, so I know that there are some questions that are left unanswered, and we could spend a lot of time talking about the specifics, but the main takeaway here is that the code at the very top of the XAML file that you add to your phone project does have a purpose. It defines the rules that your XAML code must follow. You'll almost never need to modify any of this code, but if you remove it, you could potentially break your application. So I would encourage you to not fiddle around with it unless you have a really good reason to do so. And there are a number of additional attributes that we see here in lines 10 through 14. We're going to talk about them later on in this series. All right, so in Visual Studio's Solution Designer, Solution Explorer, you can see that the XAML files have an arrow next to them like I pointed out in the previous lesson. So for this main page.xaml, there's also a little arrow that will allow us to drill down and see that there's a relationship with this main page.xaml.cs file. The only difference is that it has this .cs file extension. If you look at the CS version of the file, you'll see that it defines the main page class, and furthermore, it defines it as a partial class. All right? And so the other half of the equation is defined in lines 1 and 2 of mainpage.xaml, where we have this class equal petsounds.mainpage. Now, while it doesn't use the term partial like its procedural counterpart here, it does indicate the relationship between the two. So why is this important? Well, this relationship means that the compiler will combine the output of the mainpage.xaml and the mainpage.xaml.cs files into a single class. This means that these are two parts of a whole. That's an important concept, that the XAML gets compiled into intermediate language just like C# gets compiled into intermediate language, and they both are partial implementations of a single class. So this allows you to create an instance of a class in one file and then use it in another file, so to speak. And this is what allows me to create an instance of the media element class, and we called it what? We called it Quack Media Element, and then call its methods and properties here in the code behind without having to create an instance of it or reference it in some way. We were able to just use it, and we were able to use it because it's defined in the class just like we were had we defined our button inside of the imperative C# code that we wrote. And we'll see more examples of this a little bit later in the lesson. All right, so since XAML is essentially an XML document, we can embed elements inside of other elements. So we've already seen an example of this, right? We have this topmost XML element, this phone application page, and if we were to drill down, there is this grid called layout root, and inside of that layout grid there is this other grid called content panel. All right, and inside of that content panel grid we created a media element and a button element. All right, so here the phone application page contains a grid, and the grid contains a media element and a button. Or perhaps more correctly in XAML parlance, user controls content property is set to grid, and the grid's children collection includes the media element and a button. Depending on the type of control that you're working with, the default property can be populated using this embedded style syntax. So what we could do is this. Let's take away this word quack out of the button and set it like so here. Whoops. All right, and it would still work. You can see it, the word quack reappear in our designer. Or we can remove it back out and put it back where we originally had it. So we'll remove the content attribute and just set it here because it's a default attribute. Okay, so let's talk about another feature of XAML. We'll talk about complex properties and the property element syntax. So in some cases, merely setting attribute values masks the complexity of what's really going on behind the scenes. And a good example of this is how we set the background of our button equal to red. But if you take a look at the C# that was required to do this, we actually created a new instance of an object called the solid color brush, which we had to add a using statement because it's in the system.windows.media namespace. So this solid color brush takes a enumeration, and we selected the enumeration colors.red. Okay. And this is another example of a property type converter because, we just were able to use the word red, and behind the scenes it did all of this for us. Very cool. But some attributes are simply too complex to be represented as string values like we did here. And to kind of demonstrate this, what I want to do is go ahead and remove the background equal red. And let me put this on a different line as well. Okay. And what I want to do is actually go now into the properties pane here on the right hand side, making sure that my mouse cursor is somewhere here in the button, so that makes sure that it's the context of what we're setting here in the properties window. And I want to make sure that brush is selected and make sure that background is selected. So we're in the brush categories, background, and I'm going to change from the solid color brush to the gradient brush. And you can see when I do that, it shows me a little preview of what the background looks like with the black at the top and the white at the bottom, which is the default. You can see how that's represented over here in our preview. And so now what I'm going to do is take this little circle and I'm going to drag it all the way over here to the right hand side, the upper right hand corner, which will give me a red color. All right, and so now you can see that it changes from black at the top to red at the bottom, and there's a beautiful gradient in between. And so, pretty much the importance of this is the XAML that's generated here. No longer do we have a simple property where we can just set background equal to red. Now we have all this generated XAML. And so it's broken out into its own element. This is called a property element syntax, and it's in the form of control.property. And it's a child to the control itself. So the button control has this property element syntax to define the button.background attribute, and it's going to define it as a complex series of XAML settings. And so here we have a linear gradient brush. The term brush means that we're working with an object that represents a color or many colors. So think of brush like a paintbrush. Now this particular paintbrush will create a gradient that's linear in nature. The color will change from top to bottom or from left to right in kind of an equal proportion, I guess you could say. Now admittedly, you would never want to do what I'm doing in this code example because it goes against the aesthetic of the Windows Phone 8 application guidelines. But let's pretend for now that we're expressing our individuality by using a gradient color as the background color for a button. As you can see here in this code example, if we want to define a linear gradient brush, then we have to supply a lot of information in order for it to render the brush correctly. We have to give it the colors, at what point do we want the colors to start and stop. We give it a collection of gradient stop objects, what we should, we start with red with an offset of 1, and we start with the black with an offset of 0 and move on to red with an offset of 1, and so forth, okay, which basically is the color and their positions inside of a gradient. That's what an offset basically is. However, the XAML representing the linear gradient brush in this code snippet is actually shortened automatically by Visual Studio. Here's what it actually should be. Let me go ahead and modify this example and show you what the long form version is. Notice how the linear gradient brush dot gradient stops collection and the gradient stop collection were omitted whenever we used the properties window, the little visual designer that allowed us to choose the linear gradient. This is done for conciseness and compactness and is made possible by an intelligent XAML parser. First of all, the gradient stops property is the default property for the linear gradient brush. And then next, the gradient stops is of type gradient stop collection and implements the iList of t. The t in this case would be of type gradient stop. Given that, it's possible for the XAML parser to deduce that the only thing that could be nested inside of this linear gradient brush is one or more instances of these gradient stops, which are being added implicitly to the gradient stop collection, which is, again, set as the default property for the gradient stops collection of the linear gradient brush, okay? So the moral of the story is that XAML allows us to create instances of classes declaratively, and we have a granular fidelity of control to design user interface elements. Even so, the XAML parser is intelligent enough that it doesn't require us to include redundant code. As long as it has enough information to create this object graph correctly, then it's good to go. All right, phew. To recap, we learned a lot about the syntax of XAML. Most of XAML is pretty straightforward, but there's a few things that are not quite so obvious. XAML is simply an implementation of XML, and it relies heavily on schemas and namespaces to adhere to contracts so that different applications can create, interpret, display, or compile the XAML code. Secondly, the purpose of XAML is to allow for a compact, concise syntax to create instances of classes and to set their properties or their attributes. We compared the procedural version of a button created in C# versus one created declaratively in XAML, and we saw how much less code was required to do it that way. Third, XAML requires less code due to its built-in features like property type converters, which allows a simple string value to be converted into an instance of a class. For more complex property settings, like we saw just a moment ago, XAML offers property element syntax, which harnesses the intelligent XAML parser to rely on default properties and deduction to reduce the amount of XAML code required to express a design, like we just saw. And fifth, we learned about the embedded syntax style of and the embedded nature of elements, which suggests a relationships between visual elements. For example, the phone application page, it contains a grid for layout here, and which in turn contains a area for our content, which in turn contains a number of controls that we've added to our project. And these are represented with opening and closing elements representing containment or ownership. And then finally, we learned about the default properties. Each control has a default property which can be set using the same style of embedded syntax. And the good example of this was our value quack, okay? So that we were able to remove it as an attribute content and just set it as a default property. Okay, so next let's learn more about the grid that we saw here and we've used for layout for the content panel, and the grid that kind of wraps it, as well as our topmost area here. We're going to learn about XAML's attached property syntax and how events are wired up, all in the next lesson, so we'll see you there. Thank you.